see me now? Chat, what is wrong with you? Is it like nobody's responding? Let me just really check my Facebook really quick. I mean, dude, there are like 8 people online. Okay, that's cool. Okay. Quickly, if you guys have any questions or something which you want to clear out before we start, today's video is actually about getting into machine learning. So if you have any questions, you can just shoot at me. Okay, so guys, can you hear me? Like, type it in the chat if you can. Just with fingers. Okay. So today's video we're going to be talking about machine learning. Where darkness. Okay. This is all that we are going to have for now. Okay, cool. Okay, before we start, whatever, there it is. Okay, before I start, do I have my script ready here? No, okay, cool. Yeah, okay, before we start, what is machine learning and why do we actually need it? Okay, machine learning is concerned with it's like nobody's even online for goddamn sake. I'm just going to check if anybody's moving because I just want to be streaming for god no sense. Is anybody even there? God damn it. Okay, cool, somebody's watching. Oh, cool, my sister's watching. That's pretty odd. Oh, okay. Okay, so let's start with machine learning. Machine learning is more concerned with the idea of constructing computer programs that actually improve over time. Okay, or experience, not necessarily time, like experience, like how we learn things, like how when you start learning how to paint or being an artist generally. We learn how to paint things a little more better as we go on. So we learn from experience, like how to brush things, or like what is the best way to make a streak or something on the paint, or what is the best angle to align your paintbrush while you're painting, such things like that. Or even playing the piano. We learn by experience, by doing things, by playing music, by playing small songs, by playing or practicing small scales or major scales and minor scales. Okay, so machine learning is concerned with developing these programs to learn from their experience, like how like making a program which learns to play chess by playing chess against other people or against itself. Okay, so why would you need machine learning? Okay, machine learning is very needed in today's world. Okay, I'll give an example. Okay, consider the idea of consider playing a piano for a sort, or learning how to play a piano, or language for that matter. Okay, these things are very vast subjects. They have a lot of rules, a lot of principles. In a program, when you're generally making the program do anything, you just define the rules. Like when given input X, check if the value is so and so, if it's less than this or less than that, greater than that, and accordingly give output Y, right? But that's not possible when you have very large subjects such as language. Okay, you can't teach a program how to generate English texts. Okay, you can't do that because in language by itself is very vast. You have different things like subject, verbs, adjectives, arrangement of these things, nouns, pronouns, and another problem with language is that language can be interpreted in different ways. A sentence like I'm feeling really good and I'm feeling really good. Like they have different tones of voice. And everything. Right? You could put exclamatory mark or code which identifies that but that would not help every time. So sometimes people could you can have texts which mean the same but have a different meaning. We have words which have the same meaning, which have different meaning but have the same spelling. Right? In such cases, you can't program a computer to do things like that. Right? What you have to do is teach the computer, or at least give it some examples so it can learn by experience. For example, once you teach it, so you just give it some basic example texts of what, let's say, you can give it an input of a data set with each different types of music and different arrangements of music. Okay, and ask it to generate something similar. So as it goes on learning about different pieces which are given, okay, and it starts generating its own. In that process, it learns by doing experience. Now, today we'll be working on, today I'll be helping you to get into machine learning. I have a few books I'll show you at the end of the stream. For now, I'll just tell you what we're going to do today. Today we'll be using an algorithm called as linear regression. I know all those commerce people will be getting on me. Linear regression is from statistics and crap. Alright, yeah, I know that. But machine learning is very well known for taking algorithms and everything from other branches as well. So in the case of linear regression by itself is not of that much use actually. We need to optimize the thing. So that's what machine learning is doing. We're going to be optimizing this algorithm such that we get the best results. So it's like a bang for a buck, right? You don't want to be wasting all your processing power just to get the worst results, right? You want to get a bang for your buck. So we're using machine learning for that. So before we even get into linear regression, let's talk about what linear regression is. Okay, linear regression is the algorithm used in statistics that is used to map the relationship between two variables x and y over a graph. Let me show you an example of a graph. Okay, showing the relation between x and y values over a graph. How are they related and what are they doing? Okay, like that. That's what linear regression is used to do. Okay, then you might ask me, Rahul, why are we using this now? Okay, we are using machine learning now to predict a value. So before you even get in, let me just look into the data set which you have today. I'll be showing you today's data set. Nope, this is not the thing which I should be showing you. Okay. We'll open that. Awesome. Okay. As you can see, this is a data set which we have accumulated. not that much actually. So okay, so basically we have two values. It's x value, which is the distance traveled, and p value, which is the amount of calories burned. So we have this full set, which is the A column is our distance traveled. So here the B column is the amount of calories which you have burnt after traveling so much distance. Okay. Now let me map that for you. Okay. I don't even remember if I have matplotlib on this. It's been a long time since I come on Windows. I'm only on Windows now because I was working on this project for a client of mine. Oh, it looks like we have matplotlib. Okay. Let me just set up the thing to show you the graph. I hate when you have clean spaces that are separated. Okay. I think we should be set up now. We'll do this PLT. Now import numpy. Okay, numpy is a data science library for Python. It's mainly used for matrix multiplication. I know we could do matrix multiplication by itself because Python is very user friendly as a language. But the thing is that when you have really complicated things such as dot products and things like that, it's better off to use a library such as numpy. And this is the only library which we'll be using for the program today. So people who are like beginners in Python, yeah, it will be easy for you to get into this. So okay, now we'll just get the data. Gen from txt. Okay, gen from txt is a function that we'll be using to read data from a data CSV file. Data.csv. Okay. Okay, we have it here now. If you just print this like this, what the hell? It's saying man. How come? Are you guys able to see this? Wait. Oh shit! This should have taken it by. Okay. Now we have the values. Okay, that's what I was thinking. Why? And usually what happens is that gen from text takes a limit of comma. This is separate again. Okay, if you do data, this is an array object. Okay, for those of you who are not familiar with Python, in Python you can also declare array using the following syntax, like array. Okay, these which this actually gives this is like a built-in object, so you can built-in thing in Python, so you can have all these extra functions with that. So right there goes okay. You're gonna access these values. Okay, so it's giving you the 0 is for the index. That's for the value. 0 is for the there we go. That's what I was thinking. Yeah. Why did all this was okay? So data. Here's the things. 0 is a row, and comma. Then you have 0 or 1. 0 is a column for the x values, and 1 is a column for the column number for the y values. So you can access the 0th index. Yes, like so. Now let's plot these. Okay, so I'm just going to write some really quick Python code here. 0.4. Okay, for point in data, zero comma 1. Let me just check out. This is the problem with this stuff. Okay. How many of you are actually online watching this? Oh, cool. We have a lot of people watching it. But I'm not doing sarcastic about it. Well, this is really hard. Where were we? Okay, I'm just going to put it up and put this in the chat. I think I already did, but oh shit. Let me just log into my GitHub because there's some issues. Sit here, we'll just get into the power tuition thing. This won't take some time. Okay, by that time we'll just write the code for us. While I'm just doing this, if you guys have any questions, you can just shoot at me. Because, yeah, if you have any questions, you can ask. You can ask me if you have any questions until then. I'll just, while I sort out this thing. Yeah, I was prepared, but still, shit happens. I property atom. Okay, makes sense now. Okay, close this up. Okay, now. Okay, let's finish the while it's done. For I in range of length of, we're going to loop until the length of point, data. Going to, what we're going to be doing is data of I comma 0. Okay, image syntax blah blah blah. Oh, I forgot. This is not how you do it. Why do I keep doing this? Okay, it's I comma 0. Now we have all the x values. Yeah, see, we have all the x values. So then we will do the thing for the y and we'll plot it. The graph. instead of that we make it into 1. 2, we have all the y values. Now what we need to do is we need to plot this. So we're going to be doing plot. Okay, looks like you guys are able to see this. It's not the best thing. Okay, so x comma y comma. Okay, red O. RO is saying red circles. Or I think it's wait a second. Did we import pipe matplotlib? Oh shit, that's why. We should have import matplotlib.pyplot as plt. Wait a second. Now it should work. Plot x comma y comma ro. Okay. Now we have the thing. Okay. This is our data in a form of graph. This is our data in a form of graph. Cool, right? Maybe not the coolest thing, but yeah. So this is all data plotted in the graph. So in linear regression, what we are going to do is we are going to be drawing the line which best fits the data. So best fit in the sense, you remember the equation for a line formula from school. Okay, you remember slope of line. This is the equation of a line. The equation is given as follows: y is equal to mx plus b. Here you can see m, where m is just a denote the slope of the line, and b is a y-intercept, right? You know that. That's pretty obvious. So using this, we're going to be making the line or developing a line which best fits all this data which you have here. So let me show you the. Where the hell did I put it? Okay. It's not the graph. Okay. I don't think we have that. Wait, I think I have it on me though. If you go here, check this out. Okay, cool. This is what I'm saying. So, what we're going to be doing is basically, I'll just take this thing out. Damn. Okay. So what we'll be doing here is we'll try drawing a line, and we'll change the y and slope and the y-intercept as we go, y-intercept, such that it best fits the line. So we start here at some random point and just keep going up. We change the values until we reach the point where the line best fits the thing. Okay, we're going to be doing that now. Okay, so you guys know what dataset we're using, right? Dataset, electros and thing. Okay, that's it. This is the data which you're going to be using. And good. Okay, so just in case you guys don't remember what data set you're using, so this is the data set we're using. Okay, x is for the distance traveled, and y, x which is a column, for the distance traveled, and b for the number of calories burned. Okay, this is probably a database. Okay, so this is probably the database that Apple uses to train Siri. Okay, so this is probably the database that Apple uses to train Siri. Okay, so let's get back to the code. Today we are going to be working on everything. Okay, should probably put this dramatic. You guys see me at 8. Okay, so we'll start by importing numpy. Okay, I am not going to be doing anything that special. Let's importing numpy, and we'll just do the basics before we get into how we're going to be doing how we're going to be doing the best fit lines and stuff. Okay, we're going to be running okay, with that out of okay, without an issue. Now let's talk about how we are going to be achieving this. What is this? How we are going to be defining the best fit line. So we will be using. So remember I told you about the formula which you're using to define. So what we will be doing is we will be changing the values of y and b accordingly. But how do you know what value you should be changing and by how much? So on the slope. Okay, why that will not slope. Okay, so first in starting we'll just get some random values. Okay, and we'll compute the error by subtracting the expected value from the actual value. So we'll be using something called a sum of squares error function, which is a function which we use to calculate the error. Okay, so it's like this. Damn, and I can't even show you that. Okay, this is. Get proper to show you. I'll open it up and I'll show you here. Okay. This is the function. Damn son. Okay. This is the function which we'll be using. Let me just do something. Okay. Now it's much better. Okay, as you can see, what we'll be doing is we'll be taking each point. We have both the x and y values, right? We'll take we'll take a slot of that, okay, and use it to calculate our estimated y value. Okay, we have a slope and we have a y-intercept. We'll be using that using this formula. Okay, we'll be using this formula to calculate the y. Okay, then with this y which we have here, which is being calculated here, is our y hat or our actual y output. But this y which we have here, this is the expected output. So what we'll be doing here is that we'll be taking the expected output. We'll be taking our actual y output, which is the one which we get out of our algorithm, and subtracting it from the expected value. Then we'll be taking the square of it. Okay, we'll repeat this. We'll repeat this thing for every set of m and p values, which is slope and intercept values, until the last one. Okay, this will give us our cumulative error. Okay, based on the error value, we'll be adjusting the values for m and p. But how are we going to be adjusting these values? Let me tell you that as well. So you remember, okay, let me snap. Yeah, where is the gradient? Okay, got it. So basically what we'll be doing here is we're going to estimate the y value. How come those are not added to the stream? But let me just add those images to the stream. Just a second. I don't know why I didn't add them to the screen first. Now check once. Yeah, that is what I was saying. I don't know why I need to add this. Yes, I was talking about this. If you graph our data in a three-dimensional graph, you get where we have error, y-intercept, and slope. You get this with every value. So this is for every value of x, for every value of the y-intercept and the slope. You get this graph here. Okay, let me just take this out. For a second, take this in here. This is why I don't use OBS on Windows. It's pretty crappy. Okay, as you can see this. You can see the error value decreases and increases. Okay, in between these two mountains, there's a small valley in between. Okay, that is where the error is the least. That means the least amount. Okay, so in any machine learning algorithm, our main aim is to reduce the amount of error. So basically, error is how much we are off the actual output. That means, let's say your output was a 5 and the expected output was a 10. We are 5 units off or far away from the actual output. So that's what I'm saying. So main aim of machine learning is to reduce the amount of error. So reduce this small error. So as you see, there's a small value where the error is small. Error is really low, which is actually what we want. Okay, and this is what we call as in statistics we call it as the local minima. Okay, so now let me just take it out. One thing is that how do you approach this? So we do it using something called as, okay, bear with me. I forgot to add some of the images which are necessary for today's class, you can say. Necessary for today's class. This is not what you need now. Well, here put it. Okay, so where did I put it? That is graded. I already have the gradient. Yeah, this is what I'm partial derivatives. Yes, that's it. This is the image you're looking for. Cut out this. I'm showing something as well. Power images. Image. This is exactly what I was talking about. This will be important. Yeah. And the error function. Bloody hell. Okay, whatever. It's back to CSS. Inspect. That's it. Simple as so. Okay, now we already have a thing. Let me just put this here. So this is our error function, which I think I told you about just now. You have to remember this. This is a really important part. Okay, this is an error function which will be used to calculate the total error or sum of all the errors. Okay. So in order to calculate which direction we should go, in order to calculate that. Wait, why did you put this now? Okay. We'll go into this now. Gradient. Concept of gradient. Okay. This is gradient. Okay. So what are as you saw in our main graph, which is that. As you can see in this graph, I was telling you about minimizing the error. So it somewhat looks like a slow. So basically, we're trying to find error. But how do you find this error? We use something called as gradient descent. Okay, gradient descent is an optimizing algorithm which we'll be using to find the smallest or a local minimum. Why are we trying to find a local minima? We are trying to find a local minima to reduce the amount of error. So what we're doing is that we take a random point. So that's like a starting point. Then you find the slope. Or I mean you find a derivative. So a derivative of a function at a given point is nothing but the slope of a function at a given point. So that I have it here. This concept. This concept. Here. Alright. So basically, derivative of function at a given value is just the slope of a function at a given point. So to this we can find out if by finding a derivative we can find out if the slope is going high. That means if it's a positive value, or if it's going down, then it's a negative value. So what we need to find here is that if the slope is going down, if it's a negative value, that means you're going down. So if you're going down, that means you are reducing. There's a reducing the value is reducing. Hence, we are reaching. We are going towards the lower. We are going towards the minima, the local minima which you want. So using this concept, we will find a derivative. We will find a derivative of this error function which you just wrote here. Okay. So we'll be finding the derivative. Okay. So for the given point, we will keep finding the slope. So based on the direction of the slope, we'll go down. If the value is going, if the slope, the result of the derivative is giving us a negative value, that means you're going down. Then we don't make any changes to our this is where the hell is that equation thing? So we don't make any changes. We don't make any changes to our m and b values. But if you're going up, that means there's a positive value and the result is going up. In such cases, what we'll be doing is that we'll be reducing the m and b values accordingly. So I'll be coming up to why we'll be using that. Let me here. Okay, just for this. Thanks. Okay, is there too much disturbance? Let me just cut off the audio a bit. Okay. Can you hear me now properly? Can you hear me now? Okay, let's get back to the thing which you're doing. Okay, so I was saying. So basically you're going to be finding the slope and accordingly adjusting this. So that is gradient descent. Okay. So in order to find the slope, in order to find how much we have to adjust the values for m and b, we have something we need to find how much of a change in b, how much of a change in wait, let me bring that up again. I think I know what the issue is. I guess that should fix it. Okay. So what we're going to be doing is we're going to be calculating how much of a change in B and or change in M causes the slope to go up. Okay. How do we calculate this? We calculate it by calculating. So we need to find out firstly which variable is causing the disturbance or which variable is causing the damage. So we need to calculate a derivative for each. So basically find the slope, how much of a change in slope is caused by these two values. So we use something called as partial derivatives. So we take the partial derivative of the cost function with respect to m and b. Let me do that. Not this. What do you even name it as? This one. Yes. So we'll be calculating the partial derivative. So how do we get this value? So we do this using the power rule. Okay. The power rule, we multiply the coefficient by the exponent and subtract 1 from the exponent, which will give us the partial derivative. But then you have to calculate the derivative with respect to the values. So these are the equations. This is the partial derivative of the cost function with respect to m, and this is the partial derivative of the cost function with respect to b. Okay, now we'll be using this. Okay, we'll be using this in our algorithm to adjust the values of m and b accordingly. So if you guys have any questions or anything, that'd be really cool actually. Okay, open this up. I'll just close this down now. Now that I've cleared it up, we'll start with the code. Okay, we'll start with the code now. Okay, I'll have chat open in the bottom. So guys, if you have any questions, you can shoot me. I have no props answering them. Okay, so before I start, I'm probably going to get some power cable batteries dying. Where are you? That's the old one. Okay, we're back. I guess we're back now. Are we back? Yeah, we're live. We're live. Yeah. Are we? Hi, video. Okay. We'll just go closing this in the bottom. So basically, so before we even started, we're going to have a function called pre. I might be going against what I said in the starting, which is we're not going to be using any more libraries than that. But matplotlib.py.plt. Okay, so we're going to be using this because it's pretty. Oh shit! I have this open all the time. Okay. Let this be here so it stays in your head. And let me just get this. Okay. If you have any questions, you can ask me. I'm always open to answer. Alright. If you have any questions, you can ask me. I'm totally down to answer anything. Okay. We'll have PLT. Damn, I hate those. Okay, we'll have a function called pre. So basically, pre, what it's going to be doing is it's going to take graph our values. It's going to be graphing our values. So we find out what's the difference after and before we run the thing. So okay, we're on this thing. So everything is ready. So we'll be using, before we start, we're going to be doing data is equal to numpy. I should do npy as np. Now everything is going to be easy now. Okay, np.gen from txt. Okay, gen from txt is an inbuilt function in numpy which allows you to read CSV files. So we'll be using our traditional CSV file. Okay, now in pre, what we're going to be doing is we'll be getting the x and y values. So we're going to be getting we'll be getting the values. Okay, x values. Pardon me if I'm just doing the but this is just my one line thing which I like doing. So So this is a one line for loop. So I'll explain you when I'm done. So for data, okay, so what we're doing is we're looping from the I value, which is 0, to the length, or it's the length of the day for data. So if it's a length of 10, it's going to loop from 0 to 10. Okay, up to 10 but not 10. Okay, so it's going from 0 to 9. So that's what we're going to do here. And here points of 1 comma 0 is 0 is for the to get the values from the x column, which is the a column, and I is for every row. Okay, what this whole single line does is that it takes each every value. Okay, it takes all of these values. Let's say we have some, let me just put here as comment. We have 34. Let me just increase the size. I think you guys can follow now. So what it does is that for every value, like you have 34, 45, 56, 78. So let's say these are the values in a column. It takes that and makes an array for it. And this array, these values are fed to x. Okay, this is basically what it's doing. We'll do the same thing for y, but just for the y-axis. Okay, y here is, I don't think it should be like that. Instead, we'll call them m, b. Yeah. Nah, x and y is solved. It makes no sense then if you do that. Okay, in range of len. Similarly, it's the same thing. The only difference is that it's just they're looping to the y column. That's all. Now we're going to plot this. Plt dot plot x comma y comma ro. Ro means red circles. Okay, each point is given each point is drawn as a circle. You can also draw it as these, or you can just draw it T. But I prefer circles. Okay, and actually they're much more easier to go with. Anyways, okay, this is our plot. It's going to show up. Okay, then we'll define another function. We have another function called post. Post is basically, and we're going to give it the m comma b values. So basically what post is doing is it's going to calculate the value. We'll work on this later. I don't think it's necessary. We'll just because it's there. Okay. Now we'll have a function called compute error. It's going to basically compute error. Sorry, okay. So I remember I told you about. The, let me just bring it up instead. Not this thing. Let the partial derivatives be there. Error formula. Yes. Okay. I'll be doing that. Okay. Now back here, error formula, adjust the size. Remember I was telling you about this error formula, right? Right. We'll be writing the same thing in code now. We'll have total error to be 0. Next, for don't mind if I see towards the other side because I'm looking at another display which has everything, so I can see what I'm showing you guys. It'll be like that for some time, just until I just set up another few displays here so you can easily work on it. Okay, so for I in range of length of the points, because you won't get the value for every point. For every of those, we're going to get x. This is going to be a point. Yeah, x is a local variable, so no worries. Points I comma 0, and y is going to be the y. It's going to be the y value. So y is our expected output, not the actual output. Remember that. There's a huge difference between the expected output and actual output. So as you can see here, this thing. Okay, this part. Okay, okay, this thing. This part you see here. This y, ith y. Okay, this is our expected output, and here you see here the ith y hat. Okay, that is our actual output. That is which we get after calculating this. So I'll just run back to the code and we'll start doing that. Okay, now we're going to be doing TTL error plus equals, because we have to calculate the sum. So what we're going to be doing is, we need to calculate sum. So obvious. So y minus, y is our expected output. So y minus m, which is the slope, times x. I'll probably put another bracket for this. Close it on here. Okay, awesome. M x plus b. B is our y-intercept. Now, in Python, there's a shortcut for taking power off. So you have double star into. That'll do the square. So it's like this equation. So it's like, oh shit, I'm just going to fix this. Now I'm just going to shift the border and the camera. And drop that partial directive. Border, put it up. Thing. Okay, so as you can see here, alright, now I lost my mouse. Okay, we're calculating the error, we're just adding it. We're calculating error for those given points, for given our values for slope and y-intercept. Then we're adding that to the total error. Next, then we return TTL error divided by okay, you asked me why are you taking float? So because by default it takes by default we want the point value. Okay, so that's why we are explicitly casting it as a float. If we didn't explicitly cast it as a float, we wouldn't be able to get the point values. We could also use double, but I'm a float person, so now we have the compute value. Next, we are going to be defining run. Okay, so for run, I was planning on getting first we get the data, which already have data is already there. So okay, we'll define our hyperparameters. Okay, what are hyperparameters? So hyperparameters are like, let's consider like knobs. Okay, so like how you have thing on, let's say consider gas stove. They have a gas stove, right? There are knobs on a gas stove which adjust the amount of heat. Similarly, we have these are knobs which adjust how fast the system learns, and how fast your system learns, the number of times it's going to be going through this process of learning, and some other things. But I believe because we're just doing the basic version of this, we're going to be going through only learning rate and number of iterations. I'll be telling you what a learning rate is. Let's go to this. Not many people ask me questions. Oh, if you guys have any questions, you can still ask me. I'm just working on this. Nobody's asking questions as of so far. If you guys have any questions, you can ask me. I'm completely down to answering questions. Okay, anyways, back to the code. Okay, what is learning rate? Learning rate is how quickly you want a program to learn. They might be like, Rahul, why did you just put the learning rate to 1 million or 1 trillion? The program will learn instantaneously. Well, that's not how learning rate works actually. Learning rate works like so. If everything else fails, you just use a trusty paint. Freaking paint. It doesn't even open for us. Okay. Now that we're here, we'll close the add function. We'll keep it here. Or just off it. Okay, next. Oh, we had two. What a circumstance. What the hell? Okay, this is a final one. Okay. How it works is hold shift, okay, wait, let me just draw a graph. Okay, so learning rate, let me just draw the graph. My graph making skills are not the best, so please bear with me. I should have used a freaking mouse. Okay. Let's say this is our gradient. Alright. And this is our point here. Okay. This is where we currently are. So next, let's say that the slope of for the given point was pointing downwards. Okay, that means you're moving in the correct direction, or initially it was in the correct direction. If you have a really high learning rate, before I do that, I'll just show you this. This point here, this is a local minima, and this is where the error is least. This is what we want. Okay, so if we have a really high learning rate, if it's like in millions and trillions, what will happen is the step which you take, the next step to go to the next point, instead of, what will happen is if you have like a really high step, then instead of going here, we'll go in towards this end. So it's basically hitting too high. Okay, as a result of this, you'll be hitting too high. But if you have a too low enough learning rate, you'll be hitting too low. So the amount of distance you travel will be really low. So instead of moving here, which is what I feel is optimal, you'll be just moving towards, just be taking a really small step, which is not that much actually. Okay, so when we have a learning rate, it must be just enough such that we don't miss this point, or we don't go too low that we take too long to reach that point. So from what I've learned or what I've experienced over time, the learning rate of 0.0001 is the best. But in some situations, it may not be the same. So we'll be learning about optimizing learning rate later on. So next, we'll be having, number of iters. It's the number of iterations which is going to be running to. So probably 1000. Next, number of iterations. Okay, number of iterations is how many times we're going to be computing the error, then based on the error, optimize the function. That means how many times you're going to be computing error and optimizing the values. So let's take a loop. How many times you're going to be stuck in this loop, after which we find out the final answer. So
So it's 1000. I feel is like normal and it's basic enough. But it's recommended that you optimize this by either increasing it or decreasing it based on your experience. We'll be looking into that in the next video. Okay, so initial. Wait, let me just look into why we don't have infinite scrolling. And atom. So until then, if you guys have any questions, you can ask me. For recommended books, I have a few books. I'll be dropping the Amazon link in here. So there's this book called Machine Learning by Tom and Mitchell. Okay, so basically, if you guys are interested in learning about the theory and how machine learning works, we're not directly jumping in. If you want to have that really good maths foundation, then you can go for this book. It's really good. I'll be putting up the links in some time. But if you are if you want to just apply those algorithms directly without by having just basic understanding or ground level understanding, there's this another book called Programming Collective Intelligence. It's an O'Reilly book and it's really good. You can get these for around 1K or something. The both books. I'll be putting the links down below. Give me a second. I'll be putting down the links in a second. Okay, while I'm working on it. No, looks like you can't do that. So here comes the enter. Okay, now we can. So we have an initial p-value. Okay, let me clear this out. So we have an initial p-value. How do you get this initial p-value? Okay, there are two things that you can do. Okay. Okay. There are two approaches. You can either give it a 0. Okay. Or what I do usually is, where the hell is that? Okay, you can use the other one. I'll show you that just now. I'll just show you now. Okay, you can, otherwise you can do this. You can use the NumPy library to generate a random value, or use random. You can use this function to generate a random value for you and use that. So for now, I'll be just using the shell slope. Okay, initially we'll just go with 0 because I feel 0 is cool. Now to define all these basic hyperparameters, let's calculate the error. So we'll be printing starting Alex. I'll come. Okay. Okay. Now we'll be calculating the starting gradient. What the hell? It's not gradient. It's gradient descent. Okay, we'll be starting will be gradient descent. No, it's like if you guys have any questions, you can shoot at me. I'm ready to answer your questions. It's like really cool. Alright. B. We will set up the initial p value. M. I hope you guys are able to see this. No props, right? And error. Okay. Next. Format. Initial B. Initial M. Now you'll be using the compute error function. Okay, the compute error function accepts three values, which you remember here are b, y-intercept, the slope, and the points. So what we'll be doing here is giving up y-intercept, wait, initial p, initial m, and the points, which is data. Okay, thank you for pointing out. Let's print. Now I've done that. Print. Next. We'll be getting a BMM values. I'll be telling you how we're going to be doing this. Gradient descent. Alright, we'll be using gradient descent. Okay. Now we're going to be giving it, we'll be giving it data, initial B, initial M, and the learning rate and number of iterations. Or not, we'll define gradient descent. Def gradient descent. We should be taking points, initial B, initial M, learning rate, and the number of iterations. Okay. Now for the gradient descent, we'll be setting B to be our initial B, M to be our initial M. Alright, for I in range of, we're going to loop this. Alright, we're going to find out how far we are and accordingly do that. Okay, I in length, not length, num iters. For in that range, what we're going to be doing is we're going to be incrementing values. Let me just look at you and do that instead. Alright, so okay, so what we're going to be doing basically is we're going to be adjusting the values. Okay, we're going to be, first of all, what we're going to be doing is we're going to get the values. Okay, we'll take the initial values of B and M, apply it, compute the error for those given, compute the total error. After you get the total error, based on that, we okay, based on that, we'll calculate the partial derivative and calculate how much of it to that error did B contribute and how much did M contribute. Based on that, we'll be adjusting the values of B and M, and then we'll be changing the, after we change those values, we'll be looping again continuously. We'll loop until the number of iterations. After done, we will supposedly have reached the local minima and hence minimize errors. So we'll just do that. Okay. Now we're going to be using something else. Okay. Let me just put the links for. I'll just put the links for them here. Just not this. I'll get you this one. Okay, I think it's this one. Get this. Okay, here are the books. One. Okay. And this is book 2. There'll be 2 versions of the book actually. One is actually the older one. This is the one which is being sold in India. This is what I'm saying. Okay, that will be adding that to the stream. Okay, this is the other book. Okay, this is the other book. Cool. Now let's get back to the code. Okay, step gradient. Now step gradient. We'll be only be giving a b, our slope, our y-intercept, and okay, we'll be giving our points and the learning rate, because we tried how fast it needs to run. Now return okay, like so. Now we'll be calculating the step gradient. Okay, this is how we calculate the step gradient. I'll just tell you what functions we'll be using. First, we'll be using current B, current M, points, and and the learning rate. Cool. Now, basically, step gradient is that part of the function which I was telling you. Now, let's put up the error function. This, right? We'll be calculating the partial derivative for that. Where are we? Not this one. Yes, this one. We'll be calculating the partial derivative. Then we'll be calculating the partial derivative, and based on that value, we'll be adjusting the values for B and M. Okay, let's calculate the partial derivative. Okay. What the hell was that? What the hell is this? Wait. Okay, down. Okay, so we'll be calculating partial derivative. Okay, B underscore gradient. It's the gradient for B, and M underscore gradient. It's the gradient for M, which is the slope. Next, for I in range of length of points. This is like for every point, and generally it takes from everything from 0, but yeah. Now get the x value. Get some h2 actually. So what is okay. Points of I, comma 0 to get to x values. Y. Points of I, comma 1. Next, we are going to be calculating using this formula which I told you here. Where are we? Oh yeah, this one. This one. We're going to be using that and calculate the partial derivative for with respect to B and with respect to M. Now, how do we do that? We use the damn formula. I just told you that. Gradient is equal to 2. Right. Did I miss something? Okay. So, as you can see, there are negative values here. In calculus, constant values can be taken out of the sum or of the thing. Okay. So you can take this out and put it on the outside, out of the sum. So it'll at the end you will get the same result. So it's possible. It'll just become minus 2n, which actually makes things much more easier to write. So we do it as minus 2 by n. considering that, I actually forgot what n was. Oh yeah, n was the number of iterations. Yes. Float. How can you even forget that? Okay. If you guys have any questions, you can ask. That's really cool. While I do this. Okay. 2n into y minus current m into x plus current b. Sorry about that. Okay. Next. Now we'll be calculating the m gradient, the gradient for slope. Will be, which is pretty much the same thing. Negative 2 slash n star x star. Yeah, as you can see, doing with respect to m here, this one. So yeah, this is what I'm going to be using. Yes, partial derivatives. Okay, I'll cover that in the main video if you want, or I'll just do it in a live stream as soon as you finish this. Okay, y minus m current x, which is this, yes, this current b. If it's not m current, it's current m. Now that you run that, we have our gradients. Now that you have our gradients, this is going to calculate for every points. Yes. Now you have a total gradient. We need to find out how much are we going to be changing the values of p and m. So we do this by subtracting subtracting learning rate times the gradient. P gradient and nu m is equal to current m minus the learning rate times the m gradient. Okay, now I have those values. We're going to return them as so. Nu b comma nu m. Okay, this is a process you should be following now. Now that you have written the whole code, so far so good. Now that we have the values, we will be calculating the ending gradient. Now that we've set up a function, now we'll get the ending values. Okay, b is equal to we'll be getting ending values. If you guys have any questions, you can ask while I write the code here. Okay, so we're going to get the b value, which is just got m, and the error, compute error. We give our b, m, and data. Check this is the case. Yes. So if it's something too big, I just adjust the thing. I think this is right. Actually, this is the best font. This is the best one, I think. Okay. Now, yes. With this, we'll save it. And for the graph, yes. That's correct. Thanks for reminding me. Yes, we'll be drawing the graph as well. So we'll be doing plot of x1, x2, and y1 and y2. So we need to put x values. So we know we have, if you open up this thing to data, yes, we have checking are already open. Okay, open up. forgot to put this. Okay, put this here. Why the hell is it going on? Okay. Okay. So we know this is the x value and this is the y value, right? So we'll be feeding these x values. First we'll find a maximum. Let's give it around 70 and a minimum of around 30. Okay, we'll find out what the values are. So we'll give it. So because you're plotting a straight line. So okay. Give a value of 30. Another one of 70. We'll have our y values. Y values, as you know, we'll be using not here. Y values will be as follows. Okay, the y value is mx into b, mx plus b, right? So m, just make it into so separate ones. I'm already sleepy. Yes, m into x, which is 30 here. This put it in another one. Plus our b value. We'll do the same for our. We'll do the same for the second one. 70. We want it to be minus minus. So b minus minus means we want a straight line and it should be in blue color. So we'll do plt.show. Now it's time to run the code. Python system py. Okay, plt. Okay, what do you call it as? Let me just check if main section. Okay. Cool. Yeah. Okay. So there's something here where I miss it. Basically, I know what the issue is. Oh, you'd ought to show them. Oh, cool. Okay, still saying invite that. PLT. That's how we run it, right? Yeah. Okay, for now I just take out those plots. I'll look into why they're not working. Now run the code. What the hell? Yeah, it's 2, correct. Yeah, very right. Yeah, that's right. Come on, man. On 59. How come? Wait. Let me read the thing. I hate Python for this itself. equal to yeah. How the hell? Triple space. Actually, that should also cause an error. Actually, I guess I forgot something in here. Did I miss something? It's awkward. Okay. Okay, that's awkward. I'll just check it out. That is not supposed to happen. Irrespective of company, it's supposed to work that way. Generally. That's odd. Okay. That is fairly odd. Okay, cool. While I'm solving this, if you have any questions, you can ask me. If you have any questions, you can ask me. I'm totally down to answer questions. Yeah. Wait, this is a bit awkward. Let me just check it out. Wait, we'll just run it like this then. Which is the completely unprofessional way to do it. Run. What do you mean it's a problem? Wait, we'll make it, call it main. Invalid syntax. Now, what did I do wrong? Okay, got it. I freaking forgot to do this part. Okay. Now, it should work. Developer issues. Okay. Now, let's take this thing out and the border. The capture. Bye bye. Oh. Okay, I'm back here. Now let's run the code. It should work fine now. Just because error is not defined. Hey, why did I put array first of all? I think that's okay. That's not so. Hey, it's supposed to work. Okay. Okay. Let's see what's important. Okay. So as to prove my point, I'll be showing you what the thing is. Okay. When you run the thing, as you can see here, we started with 0 and 0, and the computed error was really high. It's like 5,000 something. After using gradients descent and optimizing the values, you're able to get a value of 0 points. For B, we have a particular value, and M is 1.5 to something. But the error substantially decreased to 118. Right? Now to prove my point that increasing the learning rate does not help us in any way. Here's an example. Let's make it 0.001. Run the same tests. Let me clear it out. Okay, now run. As you can see, for this given learning rate which we gave here, so 0.01, our error is substantially higher than before. It's 1,152, right? That is too much. Okay, right, and that is just by multiplying the learning rate by 100. Okay, what if it decreases much more? That's what, 5,369. So as I told you, when I was talking about the gradient descent thing, okay, when I was talking about gradient descent, right? Gradient descent, if you shoot too high, you miss the target by a lot, as I showed you here. But if you hit it too low, you're going to either take too long to reach the same thing. That means the number of iterations that you take to reach the local minima is increased substantially. So you can, as you saw here, this is by hitting high, this is by hitting low. That means we need to increase the number of iterations for this to reach the local minima, which is this region here. In order for it to reach this region, it has to go to multiple or more than what we expected number of iterations to reach that. Okay. And that's yeah. And that's how gradient descent works. Okay, as promised, I will be drawing the plot and something and showing you. Okay, I forgot. We have to add data as well. Okay. You plot, not plot. Okay. Now we'll have. I'll just do what I did here. Copy that, paste it. Copy paste, bros. That's never going to happen. Okay. X comma Y comma RO, as I said, is for red circles, and I like red circles. Not necessarily, but they're more readable. Okay. Now on running this, we'll have tree. No, we'll have a running rate. We'll adjust thing to what we started with. Now, okay, run 3.75. Okay. Yeah, that's what I was thinking. Okay. Now how does it work? Okay. Now it should work. Okay. This is our data without any line. We haven't optimized the line. We haven't designed any fitting line data as of now. No. Global 9.75. Oh crap. Yeah. Yes. How can I be so stupid sometimes? Okay. Okay. Again, repeat it. This is the data with no fitting line, which determines what's okay. There's no best fitting line in this. Next, after calculating, this is a line which I've drawn, which we assume to be our best fitting line, and for the most part, it does fit most of the lines. Okay, so it does, but the thing is that it's not very useful. Okay, I'll show you an example. Okay, for this value, it's like more of an average value. You won't get the exact value which you expected, but you'll get something like an average. So that's okay for basic predictions, right? But here it lacks in accuracy. So uh, we'll be working on implementing a much better and optimized version of linear regression by using Stottenham's curve. Okay, which allows instead of having a single straight line, we'll have a curve because curves have a better definition than having a straight line. So we'll be working on that in the next live stream. So until then, see you guys. You could ask me for questions. Yeah. Okay. Bye bye.